Hey guys, it is the Bearded Tangent back with more linear and angular velocity problems. So today we're going to take a look at a linear and angular velocity problem that deals with a Ferris wheel. Now, the only information we are given to begin with on this Ferris wheel is that it has a diameter of 80 feet. So the diameter of our Ferris wheel is 80 feet. Part A of this question says that we know the Ferris wheel makes one revolution every 45 seconds, and they want us to find v, which is the linear velocity of the Ferris wheel. Now, we should remember from yesterday that v is going to equal our radius times our angular velocity, and our angular velocity is going to equal radians over time. All right, so we don't currently have r, however, we do have the diameter of the Ferris wheel, so I could divide that by 2, and I would get that my radius is 40 feet. So that means I have the radius for this question. So now all I need to find is the angular velocity, which currently I have revolutions over time, which is close to being angular velocity. So what we need to do is convert this one revolution to radians. So I can multiply this and say that one revolution is the same thing as 2 pi radians. So that will eliminate the revolutions, and now I'm in the unit that I want on top and the unit I want on bottom, and so that takes care of angular velocity, and so now I multiply that times the radius, which is 40 feet. Alright, so if you punch that in your calculator, you'd get 2 pi times 40 divided by 45. And so this is going to give you 5.6 feet per second. So our Ferris wheel is going around at 5.6 feet per second. That is its linear velocity. All right, so then we move to part B on the problem. So part B says, suppose our Ferris wheel has a linear velocity of 8 feet per second. How long would it take for us to achieve one revolution around the Ferris wheel? So typically students tend to overthink this a good bit. I know the first time I tried to work it out, I overthought it. So let's look. We know a Ferris wheel is going to be a vertical circular object. We're going to get on here at the bottom. We're going to go all the way around, occasionally stopping, especially when we're at the top and we're scared of heights, and then come back and get off at the bottom. So we're going to make one revolution. Now, the problem tells us that every second we are going 8 feet around this circle. Okay, so if we want to know how many seconds it takes us to go all the way around the circle, what do we need to know about the circle? Well, we would need to know the circumference of the circle. Okay, we need to find the circumference of the circle. And so to find the circumference, we would do 2 pi r. To do the circumference of the circle, we're going to do 2 pi r. And so if we plug in 40, we get 2 pi times 40. And so this gives me a circumference of 251.33 feet. So 251.33 feet. So that's how far it is around our circle. Now, if we're covering 8 feet of that every second, then we can find out how many seconds it would take us by taking 251.3 and dividing it by 8 feet per second. And if we divide 251.33 by 8 feet per second, we would get that it is going to take us 31 seconds to get all the way around our circle. Alright, so thank you guys for watching. I'll have another video uploaded shortly going over more linear and angular velocity problems. Thanks.